Network switches, interfaces and working principles. Welcome to CCNA 200-301, Implementing and Administering Cisco Solutions, Chapter number 14, Network Switch, Interfaces and Working Principles. In this chapter, we will learn about the multiple interfaces of network switches. We will discuss about the primary function of network switches. We will discuss about the Address Resolution Protocol, ARP. Then we will explain how a network switch works in a network. Let's imagine few decades ago where the network switch doesn't exist in this world. At that time, computer networks are made up with the device called network hub. Network hubs are the layer 1 devices that is used only for the connectivity between multiple devices. Now let's see how the network hub connect the devices together and what is the working principle of network hub. Consider the diagram that shows in the screen where 4 PCs are connected to a network hub. To understand and recognize easily, we have named those PCs as Batman PC, Spider-Man PC, Superman PC and Hulk PC. All of these computers are connected together with the help of network hub. So how the computer communicate together using the network hub? The network hubs are the broadcasting devices. They broadcast the signal received at one interface to all other interface. They are not intelligent like network switches. So in this condition, what if the Batman PC want to send some traffic to Superman PC? How this scenario happen at network hub? Let's see. The Batman PC is connected to the interface number 1. The Spider-Man PC is connected to the interface number 2. Superman PC is connected to interface number 3 and the Hulk PC is connected to interface number 4. So we can name the interface as 1, 2, 3 and 4. Now let's imagine what if the Batman PC want to send some traffic to the Superman PC. So first of all, the Batman PC send that traffic to the interface number 1 of the network hub. So as we discussed, the network hub is a broadcasting device. It broadcasts the signal to every interface of it. So when the network hub receives the traffic from Batman PC, it broadcasts that traffic to interface number 2, interface number 3 and interface number 4. All of the devices, Spider-Man PC, Superman PC and Hulk PC receive the signal. But here in the communication from Batman PC, it is written the destination device is the Superman PC. So when all the devices receive the traffic, the Spider-Man PC and Hulk PC, they will receive the traffic. But in that traffic, they will understand they are not the destination devices for that traffic. So they will drop the traffic. They will not accept it. Here the Superman PC can understand the traffic is pointed to its address. So it will receive the traffic. So even the network hub broadcasts the signal to every interface. The other devices will not listen to the traffic unless it is pointed to them. Only the destination devices accept the traffic and respond to that communication. So this is the basic working principle of network hub. There are a lot of disadvantages using network hub in a network. For example, just consider this Hulk PC is a evil person. He want to listen the communication between the Batman PC to Superman PC. So in a hub network, the evil person like Hulk PC can listen what is going on in the traffic between the Batman PC and Superman PC by listening to the traffic that coming towards to it. He can use some packet sniffing tool and can understand what are the communication going on between the other devices. So in a network that contain the hubs, there is no security for the communication. This is one of the disadvantage of the network hub. Then later on what happened? The network switch introduced into the world. So basically the network switch is used to connect the multiple devices into the network. Their primary function is same like the hub, but the network communication through the hub, it was not efficient enough, and there was lot of security issue associated with network hub. To overcome this situation, the network switches introduced into this world. Unlike the network hub, the network switches are very intelligent, they are very fast, and the problem with the collision domain is resolved in network switch. They are hardware based devices, so they gave the wire speed for the network communication. Now let's discuss about the primary functions of the network switch. The point number 1. Switch is used to provide the connectivity to the devices. Yes, one of the main purpose of the network switch is to provide the network connectivity to multiple devices in that network. The devices from different manufacturer can connect to the interface of the network switch and they can communicate together. There are a lot of network protocol used by the network switch to make the connectivity between multiple devices in an efficient way. Now let's talk about the interfaces of the network switch. This is the front side view of a network switch, and from the left corner you can see the mode button. What is the function of this mode button? The mode button has multiple functions, like it can use to reset the switch, and it can help to enter the setup mode of the switch, or we can change the LED mode, or it can be used to recover the password. Now beside the mode button we can see the status LED. The main function of the status LED to display the status of the switch. Then we have USB mini Type B console port. This interface is working as a console port. If we want to configure the switches using the iOS, we can connect this cable into the console port of the network switch and connect the other end to any laptop or computer and configure the network switch using that computer. This interface provides the access to the console of the network switch for the configuration. Then we have USB Type A storage port. This is a USB port. We can connect to any USB storage devices into this interface. This interface helps to copy something from switch to USB storage and vice versa. We can use this interface to copy any file from a USB storage into the network switch. Then we have lot of Ethernet ports to connect the network devices. Depends on the number of Ethernet ports. Switches are available 4 port, 8 port, 16 port, 24 port and 48 port. These Ethernet ports are available in 3 different categories. If the interface is with 10 Mbps speed, then we call it Ethernet. If it is with 100 Mbps speed, then we call it fast Ethernet. If it is 1000 Mbps or 1 GB speed, then we call it Gigabit Ethernet. We use the Ethernet cable to make the connectivity between the network device and the network switch using these interfaces. Then at the right side, we can see the uplink port. So what is the function of this uplink port? The uplink port is used to provide the uplink to the switch. For example, we can take the connectivity from another switch to this switch using the uplink port. In the same way, we can provide the uplink to the another switch using the uplink port. The uplink port speed is available in 1 GB and 10 GB. Basically, we connect the peripherals called SFP into this uplink port to get the connectivity. The uplink interfaces are also called SFP modules. We can use an RJ45 interface or a fiber SFP module here to get the connectivity. If we are using the RJ45, then it can connect a copper cable which provide a 1 GB speed, and if we use the fiber SFP module, we can connect the fiber cable which provide a 10 GB speed. Now let's go to the backside view of the network switch. Here we can see at left side RJ45 based console port. In the front side of the switch we saw the USB based console port, and at backside there is an RJ45 console port also available. We can connect a network crossover cable to this interface and connect to a laptop, can access the console of the switch and configure it. Then we have a management interface. This management interface is using for the management purpose. We can provide an IP address to the management interface and we can manage the switch over the network. Then we have system fan. This helps to maintain the temperature of the hardware inside the switch. Then we have the power supply. This is where we provide the electricity to the switch. We can either use a single power supply or double power supply. There is a provision to add an additional power supply into the switch. Now the another function of the network switch is it learned the MAC address of the devices that connected to it. You may be wondering how the network switch send the traffic from source to the destination. That is with the help of MAC address or physical address. MAC address stands for Media Access Control Address. It is also called hardware address or physical address. A MAC address is look like this. It is a 64-bit alphanumeric address. The MAC address is a unique 12-character alphanumeric attribute that is used to identify the individual electronic devices on a network. It has two parts. The first 6 character is known as OUI, that means organizationally unique identifier. This denotes the hardware manufacturer addresses. For each hardware manufacturer, there is some specific registered OUI number. By identifying that, we can identify the hardware manufacturer. The last 6 character denote Network Interface Controller Specific or NIC. This is provided by the hardware manufacturer internally to identify the devices. The OUI is provided by IEEE committee. This IEEE committee is also known as the Institute of the Electrical and Electronics Engineer. So the IEEE committee provided a registered OUI number for all the manufacturer, and they need to use that OUI number at every electronics devices that they manufacture. Now the point number 3. Network switch store the learned MAC address to the CAM table. The CAM table is called Content Accessible Memory. This is a table that maintained by the network switch, and it is used to store the MAC address of the devices that connected to its interface. That means whenever we connect any network devices into network switch interface, it learns its MAC address and store that MAC address into the Content Accessible Memory table or CAM table. This is also called MAC address table. So in the screen we can see the MAC address table of a switch. Here we can see 4 devices connected to the network switch, and we can see its VLAN. We can see the physical address of each devices and what type of connectivity it is, and in which port that device is connected to it. This is how network switch manage the connectivity between multiple devices. Now let's understand what is happening inside a network switch when we connect the network devices into it. So consider a network switch as shown in the screen. There are 4 computers that we need to connect to the network switch to make a network connections. So initially, a network switch without any device, its MAC address table, Content Accessible Memory table is shown as empty because there is no devices connected to the network switch. Now imagine, let's connect the Batman PC into the network switch to the interface number 1. So in this picture we can see the IP address of the Batman PC is 192.168.1.101 and its MAC address or the physical address is given 0060.2F64.1505. So when we connect the Batman PC into the interface number 1 of the network switch, then the network switch learned the MAC address of the Batman PC and store that MAC address into its MAC address table. So now if we check the MAC address table, we can see one entry of the Batman PC has been added to the MAC address table of the switch. So from the MAC address table, we can see the VLAN connected to this device is number 1 and its MAC address is as shown in the screen, and the type of connection is dynamic, and the ports that this device is connected is fast Ethernet 0/1. Now let's connect the Spider-Man PC to the interface number 2 of network switch. And when we do that thing, the network switch again learn the MAC address of the Spider-Man PC and add that entry to its MAC address table. So now we got the second entry. Now let's connect the Superman PC to the interface number 3 of the network switch, and the same process repeat and we get the third entry in the MAC address table. Now let's do the same for the Hulk PC. So here we go, we get the 4th entry in the CAM table. So this is how a switch behave when any network device is connected to its interface. It learns the MAC address and it stores the MAC address into the MAC address table. Now what will happen? We know the switch is already stored all the physical address into its MAC address table. Now the switch know in which interface the Batman PC with that specific MAC address is connected to it. Same way, it recognizes the Spider-Man PC is connected to interface number 2, the Superman PC connected to interface number 3, and the Hulk PC connected to interface number 4. So next time, whenever there is a communication from Batman PC to Superman PC, the switch can recognize The traffic is going from the source MAC address to the destination MAC address, and it only forward the traffic from the interface number 1 to interface number 3, and it will not forward that traffic to the other interface. So here the communication is very efficient. Only the active interfaces are involved in this process. We know that the communication between network devices is happening with the help of an IP address. Each device in a network should have one IP address to exhibit its identity. So when the traffic passes from one IP address to another IP address, how the switch know where to forward that traffic? Because here the switch is working as a layer 2 device. The layer 2 devices doesn't deal with the IP address because the IP address is coming a part of layer 3. So how the switch can recognize the source device and the destination device? Here is the magic of ARP. So what is ARP? ARP stands for Address Resolution Protocol. This is a layer 2 protocol. Address Resolution Protocol ARP is a layer 2 protocol used to map MAC address to the IP address. All hosts on a network are located by their IP address, but NIC do not have IP address, they have MAC address. So ARP is the protocol used to associate the IP address to a MAC address. Basically saying, ARP helps to map one IP address to its MAC address and vice versa. So basically it is a IP to MAC and MAC to IP conversion. So let's discuss how the ARP help the network switch to manage the traffic. Now consider a network that include 4 PCs and one network switch. So each PC in this network has their own IP address and different physical address or the MAC address. Now when we connect these devices into the network switch, the switch start learning the MAC address of the devices and store the MAC address into its MAC address table. So the switch already know the PC1 is connected to interface number 1, PC2 is connected to its interface number 2, PC3 is connected to its interface number 3, and PC4 is connected to its interface number 4. And from the MAC address table, switch can recognize the MAC address of the PC1 is this one, MAC address of the PC2 is this one, MAC address of PC3 is this one, MAC address of PC4 is this one. So they store this MAC address in the MAC address table, so it can recognize the location of PC1, PC2, PC3 and PC4. Basically saying the switch can understand in which interface these PCs are connected. Now suppose the PC1 with IP address 192.168.1.101 want to send some traffic to the PC2 with IP address 192.168.1.102. So PC1 send the traffic from the PC1 IP address to the PC2 IP address. So when this traffic reach the interface of the switch, it can understand the source IP address is 192.168.1.101 and the destination IP address is 192.168.1.102. So switch want to send this traffic to the destination 192.168.1.102. So switch use the ARP protocol to convert this IP address into the physical MAC address. So when the switch using ARP, it can get the MAC address of the PC2. So here switch is using the protocol ARP to convert the destination IP address 192.168.1.102 to its specific MAC address. So the switch get the MAC address of the PC2, and once the switch receive the MAC address of the PC2, it will look that MAC address entry in its MAC address table. So switch can understand the MAC address called 000197912254. It is located at the interface number 2 of the switch. So it forward that traffic to that interface so the PC2 can receive the traffic. In the same way, when PC2 send the response back to the PC1, switch will use the ARP to convert the destination IP address 192.168.1.101 so that it can get the MAC address of the PC2, and the switch will match that MAC address in its MAC address table again, and it can understand The physical address of this is connected to the interface number 1 of the switch. So it forward the return traffic to that interface. So in this way, switch helps the network devices to communicate together in very efficient way. Now, let me demonstrate the concept of MAC address table and address resolution protocol. For that purpose, we are using a virtual lab based on Cisco Packet Tracer. For that, I have created a Cisco Packet Tracer virtual lab with one single network switch and 4 computers. At this moment, I haven't made any connectivity between computer and network switch. Now let me open the network switch here. Then type the command show MAC address table to see the MAC address table of the network switch. And here we can see the switch didn't learn any MAC address because none of this computer connected to the network switch. Now let me connect the computer to the network switch and see is there any change in the MAC address table. For that purpose, let me go to the connection tab, then choose the copper straight through cable. Then first I am going to connect the Batman PC to the switch. For that, let me click on the Batman PC and choose the fast Ethernet 0. Then click on the switch and make the connection to the fast Ethernet 0/1. Now here in the switch console we can see the fast Ethernet 0/1, its status changed to the up. That means it is connected. Now let me go to the command show MAC address table again, and still we cannot see the MAC address because the switch is still in learning process. Here you can see the orange color, that means switch is still learning. The connectivity is not established completely. So let's wait till this connection established. Now we can see the green color here, so that means the connection established. Now go to the same command again. Still we cannot see anything in the MAC address table. It is because even the PC is connected to switch. It didn't start any traffic. So let's go to the PC console and command prompt and type ping 192.168.1.255. This is the broadcasting address of this network. So let's ping here. And now if we go to the MAC address table of the switch, we can see the switch learned the MAC address of this Batman PC. And this is the MAC address, and it is under VLAN 1, and the connection type is dynamic, and the connected port is fast Ethernet 0/1. Now let's connect the second PC. For that, let me go to the connection tab, then connect to the Spider-Man PC Ethernet port to the switch port number 2. Then wait to complete the connectivity between the computer and the switch. Okay, now the connection established. Let's go to the same command again. Here still we can see the first entry only, because the second entry, this side Spider-Man PC didn't start any communication. So let's go to the Spider-Man PC again, command prompt, then type ping 192.168.1.255, and here go to the switch console again and show MAC address table. Now we can see it got the second entry. So this is the second entry. It is showing this MAC address is connected to the fast Ethernet 0/2. So in the same way, let me connect all the computer to the network switch. For that, I am going to connect the Superman PC to network switch, port number 3, and again the Hulk PC to the interface 4. Now all the PCs connected to the switch successfully. Now let's verify the MAC address table of the switch. For that, let me go to the switch console and type the command show MAC address table. And here we got 4 entries for all these 4 computers. So here we can see at interface 1, the Batman PC is connected, and interface number 2, Spider-Man PC is connected, interface number 3, Superman PC is connected, and interface number 4, the Hulk PC is connected. So this is how a network switch manages the MAC address table. It learned the MAC address when we connect any device to the switch, and it stored the MAC address into its MAC address table. Now let me demonstrate the address resolution protocol, or ARP. So for that, let me open the console of the network switch. and type the command show ARP. So this command is used to display the ARP entry associated with this network switch. Here we can see there are 5 entries, and here we can see these entries are learned by using the protocol Internet Protocol, and this is the IP address that we can see, the IP address in these entries. This IP address represents the IP address of these PCs and the IP address of the switch. And here we can see the hardware address. Hardware address is the MAC address of the devices. And the type of the entry, you can see the ARP. This is the protocol. And the interface. Here we can see all these entries are in VLAN 1. So the ARP is a conversion of IP address to MAC address and vice versa. Here we can see this IP address is mapped with the MAC address. This one. This is the MAC address of the network switch VLAN 1 interface, and this IP is mapped with this MAC address. This belongs to the Batman PC, and this IP is mapped with this MAC address. This is the MAC address of Spider-Man PC, and this one is the MAC address of Superman PC, and this one is the MAC address of Hulk PC. So this is the ARP result from the network switch. Now if we go to the PC, go to the command prompt, and here we can use the ARP command, ARP -A. So it will display all the ARP address this PC is learned from the network. Now let me do a ping to the broadcasting address 192.168.1.255. Now we can see we are getting the result, and then again use the ARP command, ARP -A. So here we can see this computer also got the ARP entries from that network. So this computer know this IP is mapped with this physical address that is belongs to the network switch. This IP is mapped with this physical address. I think this belongs to the Spider-Man PC, and this IP is mapped with this address that is belongs to the Superman PC. And finally this IP is mapped with this address that is belongs to the Hulk PC. And here when you compare both, you can see both ARP results are same because both learned from the MAC address. So this is the beauty of address resolution protocol. In this chapter, we have learned about the multiple interfaces of network switches. We have discussed about the primary function of the network switches. We have discussed about the address resolution protocol or ARP. And finally, we have explained how a network switch works in a network. Thank you for watching. Please subscribe to the channel for more videos.